Okay, hello everyone, my name is Nikki, and today I'm going to talk about the power of observability and how to unleash it. So we are all building software that is running on frameworks, built on top of frameworks, that are running on top of frameworks that are built on top of other people's computers, the cloud. And we are creating these very complex systems with multiple levels of abstractions. And all the time we want to know, are those systems working properly? Is everything working fine? And this is where observability comes to help. Basically, the practice of observability includes monitoring, uh, logging, and distributed tracing. And all of the three combined is what allows you to have an overview of your system. Is it working fine? Is there a problem with it, etc.? I'm going to start with the first one, with monitoring. This is what a dashboard looks like, and monitoring helps you build those kinds of dashboards. As you can see, this is a dashboard that is showing metrics for a database. You can see the memory that it uses, the CPU utilizations, the file descriptors, and a lot of useful information that when you look at it, you have this picture that is showing you, oh, is my system working or not? And the typical monitoring system is built out of a couple of components. We have the backend of the monitoring system. We also have a time series database that's doing all the magic. And we have a dashboard. The typical system combines the backend and the database together. And the time series database is a specialized database that allows you to store time series data. And time series data is data where you have a timestamp and a value that changes over time. And you have these sequences of time value, time value, time value. And the time series database is very efficient at storing this kind of information and also executing different operations on top of this data. Yeah, and the typical systems that are used for monitoring are Prometheus, Graphite, and M3DB. And for the dashboard, the typical thing that's mostly used are Prometheus UI and Grafana. And here is how the thing look in your code. Let's say that we're building a product. In our case, we have a search functionality in our system. It's a healthcare system, so you can search for patients or for their exams. And you can search for things. And you can, every time when the user searches something and you get them the search results back, you count that it's successful. Okay, the search is successful. I have a counter and I'm incrementing it. And you can see that it grows over time. This is the one thing, the counters are one abstraction that the monitoring system supports, and you can also execute different operations on top of this data that's stored. And over here you can see that we have applied an increased function on top of the data, and you can see basically how the value changes over time. And you can see at the end that it's dropped. On this graph, it's more obvious at the end that it drops to 0. You can say, okay, it's dropping to 0. Is there a bug in my code and it's not working? Or maybe it's the end of the business day and people just stopped using the software, or what happened? It gives you a flag that something is wrong. You can also measure the execution time of stuff. So you can have timers that measure the latency, the time it takes for something to be executed. And over here is an example of measuring time for our search code that is measuring the time it takes to go to the search engine, get the result back, parse them, and return them to the front end. And you can add labels to the metrics. So here you have a counter, and you can type for, you can add labels that are meaningful to your application, and later you can filter or group by those metrics. And over here you can see that we have added type of the search. And there is a different graph for how many times somebody searched for a patient, how many times they search for an exam. And if one of those two drops to 0, you can say, okay, I have a problem with my search code. Then you can dive deeper and say, okay, it's with the code for searching this entity. And it's more easy to find where the bug is. So the first tip that I have for you for today is always add domain-specific labels to your code. So you can have the context of the measurement that you're taking, and you can use this context to better evaluate the possible root cause of the issues that you're detecting or the desirable behavior that you want, so you can replicate it somewhere else in some other domain in your application. The next thing to keep in mind is called cardinality. So the cardinality basically tells you how many time series are created from each measurement. And let's go back to the previous example with the search. We want to log the type of the search, and we also want to log the application version. So if the successful search is dropped to 0, I can say, okay, for which application version this is happening, and I can say, okay, for this version, there is a bug in my code, and I can go to Git and check, okay, what are the commits there and find the problem. But the problem is that every combination between labels creates a different time series. And over here, if we say that we have 2 versions for the applications and 2 types of search, 2 by 2 makes 4 different time series that our time series database is storing. And we should avoid using high cardinality metrics, high cardinality tags, something that has a lot of different values that grows over time, because the time series database are good at storing time series data points in time, but they're not good at working with many time series and you can get to a point where you're bringing the whole database down and basically killing your monitoring infrastructure just by introducing, by an error, introducing some high cardinality tags. And the next tip that I have for you on monitoring is learn the query language. Just like we have SQL that allow us to look for data and apply operations like sum or unique or max or min, it is the same with the query language for our monitoring system, and we need to spend time to learn it. And there are some specifics on working with timers, and we also need to learn what those are, how to use percentiles, why to use percentiles, and how to use histograms, etc. And it's great, right? We have monitoring, we have set up the right labels, and how are we going to detect issues with our code? We can build those dashboards and have people sitting in front of computers all day, looking at the screens and trying to notice when something breaks. And this is very inefficient, right? And very tedious job. And this is where automatic alerts come into help. And here is an example of one alert. You can say, well, I have a success rate for my search code. And I get the success rate by dividing the number of successful responses by the number of total requests that are sent to this code. And one divided by the other gives us the success rate. And I say, okay, if the success rate drops below 70%, then it's a real issue and you need to ping the engineers that are working on this functionality. And you can have different alert values. We can say, okay, if it drops below 90%, first send a message to our Slack or Teams channel. And then if it drops below 70%, then notify the on-call engineers about the incident. And the alerting tool, the place where you define your alerts, is usually built inside the metric system. And there is a different component in it, then it allows you to define alerts and work with alerts better. And yeah, the alerting tool is built into the system. And there are a couple of things that you should keep in mind when you're thinking about alerts. Alerts should be urgent. It should be something that needs to be looked at right now. And something that's impactful, something that's important to the users care about, they care about. This is why we care about. It's important to the users, it's important to us, and alert should not notify about such important failures in our system. Also, the alert should be actionable. If your on-call engineers are getting alerts and they're like, oh, I know this alert is happening every hour, so I'm just gonna ignore it. This is creating a bad habit of people ignoring alerts. It's creating a lot of noise. People are not looking at the correct things. So alerts should be actionable, and they should be also real, something that is really breaking in your system. And there are a couple of ways to think about alerting. And the first view that you can look your alerting over is symptom-based monitoring. And symptom-based monitoring is when you monitor the symptoms of failures. One symptoms may be the number of 500 response code in your requests, or increased response time, or your email sending is not working. This is a symptom that can have multiple causes, or your users cannot log in. It's again a symptom of a problem. Maybe your database where you store the users is not working. Maybe your backend cannot communicate with the database because there's a networking issue. Maybe you have a bug in your login code. There are different causes that can trigger this symptom. And with this type of monitoring, we just look at the symptoms. On the other side, we have cause-based monitoring. For example, the database where your users cannot log in, where you store the database information, with the user information, and you cannot work with this database because there is no free disk space on the server. This is the cause of the issue why your users cannot log in. And yeah, you can cause-based monitoring, and where you're looking for specific causes of failures. And you need to keep in mind that many causes may trigger a symptom. In my previous example, users cannot log in because there's a bug in the code, the network is down, the firewall is misconfigured, the database is not working, the database doesn't have free space, it runs out of file descriptors, you have memory leak in your code. Many different causes may trigger a symptom. But at the end of the day, the user's impact is the most important thing. Basically, users want to log in, they cannot log in, and this is what they care about. They don't care if your database is not working, they don't care if your network is misconfigured, they cannot log in. And this is why it's very important to focus on symptom-based alerts, because the symptoms of issues is what your users care about. And with a single symptom-based alert, you can catch many different causes that may trigger it. And if you are wondering, well, okay, where to start replacing alerts, the best place is always pick the component that is closer to the client. So for example, in your front end, you can count the number of times that users can log in successfully or they cannot log in. And this will tell you maybe your load balancer is misconfigured, maybe you have a bug in your code in the backend, maybe your database is not working. And you can also do it in the most closer to the client place in your backend. For example, in your load balancer, in your reverse proxy, you can have request success rate for all the requests. And if the success rate of one of your endpoints falls below a certain level, you can get an alert, and this will allow you to catch all the issues with your endpoints on symptom-based level. You're not going to know what the cause is, but you will know that there is a problem, and this is super important. And great, we have alerts. We get an alert when something is broken, but now the question is how to find the issue. You start scratching your head. Okay, how to find the problem now? I know that it's in this component, and then there is a problem. And this is where logging comes into place. With logging, you have a system that aggregates the logs that your applications produce and store them in a central place. And it has typical system has a couple of components. There are your applications, then there is some infrastructure that's actually collecting the logs and storing them inside the database. And the two most popular options here are Logstash and Fluentd. And you have a database that usually a reverse index database. That's Elasticsearch, Loki, or there are other popular alternatives. You have a dashboard that Kibana is like the people automatically assume when they think about logging. And well, here is how logging look in your code, and there are different levels that you can set on your logs. You can have an info level log, warn level log, or error level log. And yeah, with info, you're just notifying if something happened in my application. With warn level, you have the semantic that maybe something is an issue and you want to look at it. And with error level, it's like, okay, this is something that is breaking. We need to check what's happening. So use appropriate log level every time when you add logging in your code. And the next super useful strategy to use over here is called structured logging. And with structured logging, you append useful key value pairs in your log that looks like this. Here, for example, we have failed to generate PDF, and then we can say, okay, for this particular template. And then I can go in my Kibana and I can say, okay, group this message by the template name. And I can say, okay, for this template, there are 19 such errors. For this template, there are 3, and there are no other errors for other templates. It basically groups and sums by those key value pairs, and it allows you to troubleshoot easier. You can say, okay, the problem is with this specific template. Maybe the HTML there is broken or something, and I can look at it and, yeah, find the issue easier. And always put your log statements after something happens, not before that. So for example, if you want to record that a search request is successful, return the response and then log that it's successful. And we have monitoring, logging, alerts that show us the health of a single component, but sometimes we have this complex system of interconnected services, components that talk with each other. And we want to be able to also troubleshoot those systems to see how the behavior of the system changes under load over time, what are the slowest requests, what are the certain requests that are failing, what is the path that these requests go through. And in order to illustrate this, I need a more complex example. So let's say we have a client that first needs to authenticate to the authentication service. Then it need to go to the billing service and say, okay, did the user pay for something? And then they can go to the third service, that's resource service, and then they can return the resource if the user is authenticated and they paid to access it. And you can see that over here we have a scenario where our logic, where our execution flow goes through a couple of services. And with monitoring and alert and logging alone, it's very hard to figure out the end-to-end flow. And this is where the next thing comes into place. Distributed tracing transforms the previous picture into this thing. And each line here is called a span, and you can zoom inside it, and you can see, okay, the client started the transaction. In blue, you can see how much time it took for the execution inside the load balancer. Then you can see how much time it took for the execution of the request inside the authentication service, for the execution of this request inside the billing service, and then in the resource service. And you can also dig deeper and say, okay, what are the functions that are the components inside this service that were executed. You can see how much time each of those takes. There are different tracing systems out there that you can pick from. This is one example of such a system, Jaeger, that's very popular. Here you can see that on the left side you have a menu that allows you to filter traces. You can say, okay, give me all requests that originate from this service or that terminate in this service. You can say, okay, give me all requests in this time span or that has these labels. And then on the right side you see the results, and you can see this graph where it shows you how much time it takes for an end-to-end request to be executed. You can see the outliers. Click on the outliers. And then here is what you see. Basically, this picture that's showing you which steps are executed in parallel, which steps are sequential, how much time it takes to query different databases. Over here we have MySQL, MongoDB, and you can even dig deeper and see the SQL queries or the MongoDB requests that were executed. And basically, you can also add additional information to those spans. You can add logs inside each of those. This is how you add your SQL statement inside your span where you're making a request to the database. This is where you can also add some domain-specific information. Something to keep in mind is to always add logs and tags to your traces. So you can easier filter those out and debug issues when you have such issues. And another thing to keep in mind is always add trace ID to logs. Your logging infrastructure can add keywords that are added by default when the thing starts up. For example, it adds the IP address where the log was produced or the application name, and you can configure it to add also the trace ID. This will allow you to, when you see a certain trace in your tracing system, get the trace ID, open your logs, filter your more detailed logs to see what you're looking for. Basically, easier debug it. And my next recommendation is always add consistent labels across metrics, logs, and traces. So when you have, for example, the type of the search always added to your logging with the same type search in your metrics, in your logs, in your traces, and this will allow you to cross-reference between the three. You can say, okay, let me see the logs that are related to searching for patients, for example. Let's see the metrics, let's see the traces, and yeah, you'll be able to more easily correlate the three systems. And the last thing that I have for you today is something to look forward to. So you can see that the three things are very interconnected. And one of the advices is put logs inside traces, put trace ID inside logs, use consistent labels between the three systems. You can see, okay, it looks like the three are interconnected. Why we are using three different systems for this thing? Shouldn't there be one standard to rule them all and one system to use it? And this is where OpenTelemetry comes into place. It's a standard that's just getting started to be adopted, that has the client libraries, the backend infrastructure that allows you to use one client library, get monitoring, logging, distributed tracing with a single instrumentation, and then have the backend take care of storing the correct piece of information inside the correct type of database, because it needs a different database, it's a different type of data that has its own different query characteristics, storage optimizations needs, querying specificities, and everything that's related to this. And with this, I want to thank you for your time, and I'm looking forward to your questions. Yeah. Yeah.
Year they've changed.
Yeah.
They've changed their licensing model from Apache 2.0 to AGPL.
Yeah.
How did that affect you, and what did you do to deal with it?
Well, it affects. So basically, if you're really investing in something, you get it's better to get a support for it. So there is a different, you can basically buy support for those things, and then there is different things that you're running. But if you don't want their open source projects, you can use those. If you're distributing them, you need to, in part of some stuff, you need to open source the whole stuff, right? But if it's part of your SaaS application, then and you're not selling it. The problem was with another company basically putting these kinds of software. Exactly, Elasticsearch was a good example. Was maybe the trigger that triggered this. So if you get Elasticsearch, you put something in front of Elasticsearch and you start selling this. This is where you get into problem, right? But if you're using it for your operations, then it's a different story. You cannot sell other people's things, just by rebranding them. And this is what you're referring to, right? And the thing
exactly.
that you need to keep in mind. Yeah.
Thanks.
Some other questions? Yeah. Yeah. Yeah, so the question was, how do you decide what is the best system to pick? You have different options for monitoring, for logging, for tracing. How do you pick what to do? So you look at your infrastructure that you're already using. For example, if you're using a lot of cloud native foundation projects, then you go to the Cloud Native Foundation website, you see what are the things that are part of this initiative, and then the things that are inside the same ecosystem integrate very well with each other. If you're running more Apache stuff, then you go to the Apache project and you check there. You also, if you have experience, then with some stuff that it's a no-brainer, you can use the thing that you're most experienced with. At the end of the day, it's like every software. You pick different options, you evaluate the pros and cons of each option inside your context, and you pick what's best in your context. It depends on the infrastructure that you're running. If you're in a cloud, you can use some managed solutions. If you're on-prem or if you're running your own infrastructure, then you need to also run your monitoring infrastructure. And there is a third options. There are SaaS-based products that you can use as a service. You just instrument your code. And there are wonderful solutions out there that works with kernel modules. And you just add some extensions to your kernels where your applications are running, and then you have observability that includes distributed tracing and monitoring. There are many different options. You need to pick what's best for you. If you're okay with spending money, and you want faster time to market, you want something that's running just out of the box, you don't have a team to support the system, then you pick either a managed solution or a SaaS-based solution. If you it's more efficient for you to have your team supporting you running the systems, then you pick the system and you run it yourself. So yeah, it really depends on the context, and you need to be aware of your context and work inside of it.